Okay, so we studied this chapter 3, which discusses about specialization and trade. And we finished the small village example, right? So the story was basically about there was a rancher and there was a farmer who lived in the village, and in the beginning they basically were self-sufficient, so they grow what they eat. And then after a while, an economist came and gave them some advice. So the advice was a two-piece advice. The first piece is there should be some specialization. That is, the rancher would focus on raising the cattle, and the farmer would focus on growing potatoes. And then the second piece of advice is about trade. So the rancher and the farmer would trade with each other. And then in the end, we find out a very interesting result. That is, through this specialization and trade, both of the farmer and the rancher, they're strictly better off, right? So they have higher consumption. This basically implies that the farmer and rancher will be very happy to take the economist's advice. And graphically, you could also see this. That is, before this specialization and trade, the farmer and the rancher, they could only stay on the production possibilities curve, right? They would only stay at this A and this B here. And after specialization and trade, both of them will be better off. In terms of the picture here, it basically shows that after specialization and trade, the farmer will achieve the consumption bundle at A star, which is actually outside of its which is actually outside of his production possibility frontier, right? And then this result is the same with respect to the rancher. The rancher's new consumption point, B star, is outside of his production possibilities frontier, right? So basically, this implies through specialization and trade, both the rancher and the farmer, they're better off, right? Okay, so before trying to understand why specialization and trade would make them better off, and how should we decide who specializes in what, so first let's do a practice and learn how to use the tool of this production possibilities frontier, and to understand how this specialization trade would affect the consumptions. Now, we have two countries, Canada and Japan, and we have two consumption goods, computers and wheat, and there's only one resource, which is labor, and it is measured in hours. So labor will be used to produce computers and wheat. And we will look at how much of both goods each country produces. There are two cases we want to consider here, just like the small village example. First, we consider the case when the country chooses to be self-sufficient. And second, we consider the case if one country trades with a different country. Of course, in the second case, there will be specialization. Right? Okay, now let's first focus on the simple case. That is, there is no trade. Each country will just produce and will just eat what it has produced. So now let's see. Now let's first start with Canada. So Canada has 40,000 hours of labor, right? And then we assume producing one computer, right? So 100 hours for one computer. This is essentially Canada's productivity in producing computer. And it requires 10 hours to produce wheat, right? 1 unit or 1 ton of wheat. Now we want to first start with Canada's production possibilities frontier. So what we would do here is we would take this number, the total number of hours, and we would divide 50,000 hours by the productivity numbers, right? Then we will find out what is the total amount of computers Canada can produce if it decides to put all its resources into producing computers. And we could also find out what is the maximum number of wheat Canada can produce, right? So basically we would use, for computers, right, we would use 50,000 divided by 100. Of course, this gives us 500, right? And then we would use 50,000 divided by 10, so we would have 5,000. Now, now what we can do next is to draw out Canada's production possibilities frontier. So, okay, let me follow the textbook. So if I put horizontal axis, if I put computer on the horizontal axis, if I put wheat on the vertical axis. Now what you can see here is the maximum number of computers is given by 500. And the maximum number of wheat is given by 5,000. And then if we assume the frontier is a straight line, then we could just basically connect these two numbers. So this gives us Canada's production possibilities frontier. Right? This is very simple, and I think you guys have done this in your homework, and we have actually done this in in the first lecture. Now, let's suppose Canada will just use half its labor to produce computer, and the other half of its labor to produce wheat. So basically you can see that the consumption will be in the middle point. So the production and the consumption will be in the middle point between 5,000 and 500, right? Because Canada is using half of its resources to produce each product. So what are the numbers on this middle point? Well, you can see that it's the middle point. So basically, Canada will produce 250 computers and 2,500 tons of wheat. Okay, great. So this is our first result. That is, we find out Canada will produce this amount of computers and this amount of wheat. Okay, now let's look at Japan. Well, it's the same process, right? Just different numbers. So I will do this in a more quicker way, right? So Japan has this 30,000 hours, and it has 1 to 5 hours of labor. Sorry. And producing one computer requires 1 to 5 hours of labor, and producing 1 ton of wheat requires 25 hours of labor. So in this case, you can see that for computer, we would use 30,000 divided by 125. So this gives us 240 computers. And next, we would use 30,000 divided by 25 hours of labor. So this gives us 1,200 tons of wheat. Right? Again, we could do the same process as we did for Canada. So we would draw out the frontier for Japan. So we have wheat here. And then in this case, you can see that there's this 240 computer, and then we have this 1200 wheat. Right? So again, assuming a straight line frontier. So we would have a frontier looking like this. And then we assume Japan will spend half its labors into producing computer and the other half of its labors into producing wheat. So in this case, the consumption and production will again be at this middle point. So we will have 120 computers and 600 wheat. Right? So this is our second result. That is, without trade, Japan will produce 120 computers and 200 tons of wheat. Okay. Now let's discuss the case when there is trade. So now we assume Canada and Japan, they can trade with each other. Of course, if you're thinking about trade, generally you have to think about specialization before talking about trade, right? So clearly here we have to make some assumptions on which country will focus on producing which product. So let's say here, let's say we assume basically Japan will focus on producing computers, and Canada will be more specialized in producing wheat. Okay. Now let's say Canada decides to use 34,000 hours to produce wheat. And we know that the total labor hours available to Canada are, let me think, 50,000 hours, right? So the other 16,000 hours would be used to produce computer. And we know that to produce wheat, Canada needs 10 hours per ton of wheat, right? So here we can find out Canada will produce 3,400, right? So 3,400 tons of wheat. And then Canada needs 100 hours for one computer. So Canada will produce 160 computers. What about Japan? Well, we suppose Japan will fully specialize in producing computers. And then Japan has 30,000 labor hours. And let's look at Japan's productivity. And to produce computers, Japan requires 125. So the total computers Japan can produce is given by 240. So in this case, you can see that Japan will produce 240 computers, right? So basically, this, and this tells us what is the production of these two countries. Right? Now let's start thinking about trade. How Japan and Canada will trade. Right? Of course, you can see that under specialization, we will have different production here. This page is basically a visualization of Canada's production. Right? So we have 160 and 32. And 3400 here. And for Japan, it will fully focus on producing computers. So it's 240 computers and 0 tons of wheat. Okay, now let's think about trade. When you're thinking about trade, you have to think this exchange rate or the price of products when two countries are trading with each other. So here we assume Canada can export 700 tons of wheat to Japan and imports 110 computers from Japan. So it's like Canada is using 700 tons of wheat in exchange for 110 computers from Japan. Or you could say, by the same spirit, right? Japan is using 110 computers in exchange for 700 tons of wheat. Now, let's see how much of each good is consumed in Canada and how much of each good is consumed in Japan, right? This is pretty simple because we know that for Canada, it will produce 160 computers and 3,400 wheat. And now, Canada will give up 700 tons of wheat in exchange for 110 computers. So you can see that we will add this 110 computers to the to Canada's original number of computers, 160, right? And we have to minus 700 from the wheat production, that is 3,400. So in the end, the consumption of Canada will be given by 270 units of computers and 2,700 tons of wheat. Now, what you can see here, if you draw or if you mark this new consumption pairs on this production possibilities frontier, what you can see here is this 270 is actually outside of its production frontier, right? This is exactly the case we have discussed in the example of small village, right? After specialization and trade, the two countries, they can consume consumption pairs which were not available when they were in isolation. Now we could do the same with respect to Japan. What you can see here is clearly Japan will just produce 240 computers. And now we can see that it will give up 110 computers for 700 tons of wheat. So here you can see that the amount consumed by Japan is given by 130 computers and 700 wheat. Again, we could repeat the same process of plotting this new consumption pair on this production possibilities frontier. So you will observe the same thing. That is, this bundle is actually beyond the original frontier. It is outside of the frontier, right? So this again implies that now Japan is better off because of the specialization and the trading between these two countries. So let's summarize our findings, right? So we have two countries, Canada and Japan, and we have two different cases, without trade and with trade. Okay, let me use different colors. So without trade and with trade. And we have two different consumption goods, wheat and computers. Now what you can see here is for Canada, if there was no trade, it could only consume 250 computers, and because of trade, it would consume 20 units more. Then for wheat, after specialization and trade, Canada could get 200 units more. Right? For Japan, no trade, 1 to 0 of computers. With trade, 130 units of computers. So there are 10 units more of computers for consumption because of the specialization and trade. And then you can see that there is this 100 more tons of wheat because of trade. So basically this exercise is in the same spirit as our small village example, right? The process was actually roughly the same. what you would do is you would look at their productivities, right? That is how many hours or how much time they need for production. And then given the total hours or total minutes they have, you could calculate what are their maximum production levels. So based on this maximum production level, you could draw out their production possibilities frontier. And then you could talk about specialization and trade, right? So given some, if specialization and trade were given, then you could actually find out some new consumption pairs. And you will find out these new consumption pairs are actually better compared with those original consumption pairs when there were no trade and no specialization, right? Okay, now let's look at this quick quiz here. Draw an example of a production possibilities frontier for Robinson Crusoe. A sailor who spent his time gathering coconuts and catching fish. Okay, I mean, this is just like tremendously easy, right? So this guy is gathering coconuts and catching fish. Draw this production possibilities frontier. Well, we don't have any number here, so let's just assume the frontier is like this, right? Does this frontier limit Crusoe's consumption of coconuts and fish if he lives by himself? The answer is yes. So basically, this guy can only consume within the boundary of this frontier, right? The best case he can get is to consume on this production frontier line, right? Does he face the same limits if he can trade with natives on the island? Well, he does not face the same limits, right? Because we have learned in both previous examples, in the small village example and in the Canada and Japan example, if two parties can specialize and trade with each other, then they can actually get a consumption level which is outside of their production possibilities frontier. So here, the result or the answer is the same. That is, if Robinson Crusoe, whatever, and natives, they can specialize in what they're doing best, then they trade with each other, then this guy's consumption can go outside of his production possibilities frontier, right? So maybe through specialization and trade, he could get a point like this, right? That is completely possible. Okay, now let's discuss the important question or answer the important question. That is, if specialization and trade are so great, then how do we determine specialization, right? Who should specialize in what? That's the fundamental question here. So before talking about that, we need to first understand absolute advantage and comparative advantage. So let's first define these two concepts. Again, let's look back to our old small village example, right? We have this farmer and rancher, and we have their productivities, right? Now, if you look at this table, you will see a quite interesting result. That is, rancher is actually better than farmer in doing both things, right? Because the rancher only needs 20 minutes per kg for producing meat, and farmer needs 60 minutes, and rancher needs 10 minutes per kilograms of for potatoes, but farmer needs 15 minutes. So rancher is this more productive guy in both productions, right? So, I mean, you could also see this result from the table on this right hand side, right? So you can see that using 8 hours, rancher could produce more in both meat and potatoes. Does this imply rancher should specialize in both? Of course not. I mean, this is very easy to understand because both the rancher and the farmer, they have the same amount of time. If you let rancher to do both things, now what farmer should do, right? Okay, I think I am talking. I am actually sort of talking about comparative advantage here, but let's first ignore that part. So let's start with absolute advantage. So here you can see that rancher is better in both activities. So we call that rancher has this absolute advantage in both producing meat and in both producing potatoes than the farmer. Right? So let me find the definition here. Now, what is absolute advantage is about? Well, it's about the comparison among producers of a good according to their productivity. So basically, for a certain type of production, if a producer has higher productivity, then we say this producer has absolute advantage in that specific type of production, right? Okay, now let's talk about comparative advantage. Specialization is determined by comparative advantage, not by absolute advantage. So that's why it's important for you to understand comparative advantage. Now, to understand comparative advantage, the starting point would be about opportunity cost. Remember we discussed opportunity cost in the first lecture, right? And we said, well, what is opportunity cost? It's the best choice, the best alternative choice you have to give up to obtain something, right? For example, now you're listening to my lecture. Well, I hope it's not that boring, right? Now you're sitting here listening to my lecture. And obviously, you have to give up something to sit here to listen to this lecture, right? Now, just ask yourself, what's the best thing you would want to do if you were not sitting here listening to my lecture, right? Maybe you want to watch a movie. You want to watch a movie on Netflix. So the pleasure you have to give up from watching the movie on Netflix is the opportunity cost you're paying for listening to this lecture, right? So this is basically a general, a more general example about opportunity cost. To be more specific, we can discuss opportunity cost in our small village example. Now, just look at this. I have to warn you that this part is important. It's important for you to understand comparative advantage. So please pay attention. Now, let's look at farmer, right? So this guy can actually use 60 minutes to produce 1 kilogram of meat. But he could also use 1 hour or 6 minutes to produce potatoes. How many potatoes he can produce using 1 hour of labor? Well, his productivity is 15 minutes per kg for potatoes. So this shows using 1 hour, the farmer can produce 1 kilogram of meat or 4 kilograms of potatoes. What's the implication of this statement? The implication here is the farmer can only use 1 hour to produce meat or potatoes. He cannot do both. So in this case, if the farmer decides to use 1 hour to produce meat, he has to give up 4 kilograms of potatoes, right? So here that's the opportunity cost, right? Now let's do another exercise, right? Let's look at rancher. So we change to a different person and we change to a different product, right? Let's look at rancher's opportunity cost of producing potatoes, right? Now, the rancher can spend 10 minutes to produce 1 kilogram of potatoes, and the rancher could also use the 10 minutes to produce meat. And rancher's productivity of meat is 20 minutes per kilogram. So this implies using 10 minutes, the rancher can produce 0.5 kilograms of meat, right? So this implies rancher's opportunity cost of producing 1 kilogram of potatoes is 0.5 is to give up 0.5 kilograms of meat, right? So that's the opportunity cost calculation in the case of small village example. Now, why this is important? Well, because comparative advantage is based on opportunity cost. Right? First, what is this comparative advantage is about? Well, it is about the comparison among producers of a good according to their opportunity cost. This is different from absolute advantage, right? Absolute advantage is about the comparison among producers according to their productivity. Obviously, productivity is not equal to opportunity cost. So absolute advantage is not equal to comparative advantage. And for a producer, if it has smaller opportunity of producing a certain product, then we would say the producer has a comparative advantage in producing that product. So if we go back to this example, let's do some calculation here, right? Let's say we want to compare farmer and rancher's opportunity cost of producing meat, right? So for this farmer, so we are looking at opportunity cost of producing meat. For the farmer, we have answered this. That is, the opportunity cost of producing meat for the farmer is 4 kilograms of potatoes, right? Now, what about the rancher? Well, for the rancher, to producing 1 kilogram of meat, he has to give up 20 minutes. And this 20 minutes can be used to produce 2 kilograms of potatoes. So, 2 kilograms of potatoes. Now, who has a comparative advantage in producing meat? Well, this is easy, right? Because we know that the rancher's opportunity cost is 2, farmer's opportunity cost is 4. So basically you can see that in this case, this guy, rancher, right? Rancher will have comparative advantage, right, in producing meat. Okay, It's great. Let me see the lecture note here. So we basically just finished the opportunity cost of producing meat. We could also do the same, right? So let's practice for a second time to calculate the opportunity cost of producing potatoes, right? So we're trying to solve the opportunity cost of producing potatoes. Now, for farmer, right? If the farmer decides to produce potatoes, it needs to spend 15 minutes for 1 kilogram of potatoes. And using 15 minutes, the farmer can actually produce 0.25 kilogram of meat, right? How do you get this 0.25? Well, it's just 15 divided by 60. Right? And then for 1 kilogram of potato, the rancher needs 10 minutes, and the 10 minutes can be used to produce 0.5 kilograms of meat. Right? So in this case, you can see that this guy, farmer. So farmer has lower opportunity cost in producing potatoes. That is, farmer has a comparative advantage in producing potatoes. Okay, great. Now, what's the before talking about the determination of specialization, let me make one comment. So the comment here is, it is possible for one person to have an absolute advantage in both productions. We have seen this, right? Because in the small village example, we have seen that the rancher is better. Let me go back to you can see that here the rancher is better than the farmer in both productions. However, an important result is it's not possible for one person to have a comparative advantage in both goods. Okay? This is not possible. So let me first read this page here and to give you this reason, and then I will show you this actual calculation. So the reason is because for the same person, the opportunity cost of one good is the inverse of the opportunity cost of the other good. So if one person's opportunity cost of one good is relatively high, then his opportunity cost of the other good must be relatively low. Now, how do you see this? How do you see this here? Well, it's actually pretty simple. So you can see that for this guy, farmer, its opportunity cost of producing 1 kilogram of meat is 4 potatoes. Then its opportunity cost of producing 1 kilogram of potatoes has to be the inverse of the opportunity cost of producing 1 kilograms of meat. That is, if you have 4 here, this number has to be 1 over 4, right? Obviously, 1 over 4 is the inverse of 4. And for rancher, if it has 2 kg potatoes, then you can see that the opportunity cost of producing 1 kg of potatoes would be 1 over 2, right? So you can see that this inverse relationship determines that there's no way a certain producer could have comparative advantage in both productions, right? For example, if rancher has comparative advantage in producing, in our case, rancher has comparative advantage in producing meat, right? This implies 2 is smaller than 4, right? So this sign is this inequality sign, right? 2 is smaller than 4. Well, if 2 is smaller than 4, then obviously 1 over 2, it has to be larger than 1 over 4, right? So the key here is you have to look at these two signs, right? So this sign, the inequality sign, will be reversed after taking this inverse. So it means if rancher is better, sorry, I should not use better. If rancher has comparative advantage in producing meat, then farmer will definitely has the comparative advantage in producing potatoes. Okay. So why do we talk about comparative advantage? Well, this is because the gains from specialization and trade are based on comparative advantage. It is not an absolute advantage. Basically, you should let the person with the comparative advantage specialize in what he is best, right? So in this case, you can see that we should basically let a rancher to focus on, we should basically let a rancher to focus on producing potatoes. And we should let farmer to focus on producing meat, right? Okay. What else? Okay. Oh, we could basically revisit, right? We could basically revisit the previous example, this small village example. So we have said the opportunity cost of producing meat is given by 4 and 2. In this case, we can find out the rancher has, so the rancher has this comparative advantage in producing meat, right? Because his opportunity cost is smaller. And farmer will focus on producing potato, right? Because this 0.25 is smaller. So you can see that the advice given by this economist actually follows this recipe here, right? You can see that the farmer would only produce potato, right? And then the rancher will spend a larger fraction of his time on producing meat, right? So this satisfies the specialization result, right? Okay, great. Of course, you can see in the end, both of the farmer and the rancher, they're better off. Okay, that's great. Okay, next, let's talk about, next, let's talk about the relative price when rancher and the farmer trades with each other. So before that, I still have to summarize, right? So trade can basically benefit everyone in society because it allows people to specialize in activities in which they have a comparative advantage. Okay, let me
maybe I should add some comments here. So basically, whenever you have a problem or exam, you will have a starting point like this. This is your starting point. Basically, the problem or homework will just tell you some productivity numbers. And then you will start with this productivity number, and you will convert this productivity number into opportunity cost, right? So that's like the first step of solving this specialization problem, right? You will convert productivity numbers into opportunity cost. And then you will use opportunity cost to determine who has a comparative advantage. And after that, you will determine who will want to specialize in what, right? So basically, you can see that in this case, we will convert these productivity numbers. That is, how many minutes for 1 kilogram of meat or potatoes. We will convert this into the opportunity cost. And we find out rancher has lower opportunity cost in producing meat. So we find out rancher has a comparative advantage in producing meat. And then we find out the farmer has a lower opportunity cost in producing potato. So farmer will focus on will focus on producing potatoes, and the rancher would focus on producing meat. So basically, everyone with some specific comparative advantage would focus on what they're doing best, right? Okay, the last point is about the price of trade. Right? If you look at this small village example, you will think, well, there was no price of trade, right? Because, well, there was trade, but you cannot explicitly see the price, right? If you look at how they traded with each other, you can see that this was their trade. Right? Of course, you cannot see a price here. However, you can actually express these. I mean, generally, when people think about price, it's about how many dollars for a certain item. Here, we don't have dollars. However, we can use for farmer, we can use how many potatoes, right, to buy the meat. For the rancher, we can use how many kilograms of meat to buy potatoes, right? Let's see what is the price of trade. So if you focus on the farmer, right, the farmer gets 5 kg of meat and gives up 15 kilograms of potatoes. This is equivalent to say this farmer is paying 15 kilograms of potatoes to buy 5 kilograms of meat. So what's the price? Well, the price is essentially for 1 kilograms of meat, right? The price is three kilograms of potato, right? And you could do the same thing with respect to rancher. So rancher is essentially paying 5 kg of meat to buy 15 kg of potatoes. So here, the price for 1 kg of potatoes is 5 divided by 15, right? So it's essentially 1/3 meat, right? Okay. Now, let's see why a price like this makes sense, right? You can see here, if you focus on the opportunity cost of meat, you can see that In the rancher's opportunity cost of meat is 2 kilograms of potatoes, and the farmer's opportunity cost is 4 kilograms of potatoes. And we know that in this case, right, we know that who is the buyer here? Well, farmer is the buyer, right? We are talking about buying potatoes, right? So, oh, sorry. Sorry. We are talking about buying meat. So farmer is the buyer of meat, and rancher is the seller of meat. Now think about this. For the buyer, its opportunity cost of producing 1 kilogram of meat is given by 4 kilograms of potatoes. So 4 is essentially the buyer's production cost, right? And for the seller, its production cost is given by 2 kilograms of potatoes. So you can imagine that the price has to be between 2 and 4. That is, the price has to be higher than 2. In this case, the seller will be willing to sell. And the price will have to be lower than 4. In this case, farmer, the buyer, will be happy to buy. So that's why you can see that 3 kilograms of potatoes for 1 kilogram of meat is a reasonable price in the market, right? So the number 3 is just between 2 and 4. Now we could argue the same thing for this case. Right? Now we are talking about rancher as a buyer of potato, right? So here, let me remove this. So here we are talking about the market for potatoes. So here, rancher is the buyer. Right? And farmer is the seller. So you can see that the price of 1 kilogram of potatoes has to be between 0.25 and 0.5, right? When the price is higher than 0.25, then farmer, the seller, will be happy to sell. And when the price is below 0.5, then rancher, the buyer, will be happy to buy, right? So that's why you can see that 1/3 kilogram of meat per kilograms of potato is the reasonable price. And you can also imagine what happens if we have a price of 0.1, right? So let's say the price for 1 kilogram of potato is 0.1 kg of meat, right? So let's say this is the price. What you can see here is the price is actually too low, right? It is lower than both the farmers and ranchers' opportunity costs. This implies that both of the farmer and the rancher will want to buy 1 kg of potatoes with 0.1 kg of meat. But this is not possible, right? Because we only have 2 producers in the market. So one has to be buyer and another one has to be the seller. Right? You could also argue the same thing for this other extreme case. Let's say the price of potatoes is fairly high. It's 1 kg of 1 kg meat for 1 kg potatoes. So what you can see here is, in this case, the price is higher than both farmer and rancher's opportunity costs. So both of the farmer and the rancher will want to become a seller. However, you can see that, hey, we only have 2 producers in the market. So if both will want to become seller, who would want to become the seller, right? For a transaction to happen, you have to have two parties, buyer and seller. So you can see that again, this this 1 kg meat per 1 kg of potatoes, this high potato price cannot be true in this market. Okay, let me, oops, I think I have some formula here. Okay, so let's summarize. So basically, the price has to be between the seller's opportunity cost and buyer's opportunity cost, right? To be more specific, lower than the buyer's opportunity cost, higher than the seller's opportunity cost. That's the takeaway about the the section on price of trade. Okay, now let's finish this example. Robinson Crusoe can gather 10 coconuts or catch 1 fish per hour. His Friday can gather 30 coconuts or catch 2 fish per hour. What is Crusoe's opportunity cost of catching 1 fish? Well, you can see that for 1 hour, Robinson Crusoe can catch 1 fish or gather 10 coconuts. So I can see that here to catch 1 fish, he has to give up 10 coconuts. So here we are having this opportunity cost here. So it's 10 coconuts. What about Friday? Well, to catch 2 fish, Friday has to give up 30 coconuts. So the opportunity cost for 1 fish is given by 15 coconuts. Also, you can see that Robinson Crusoe has a comparative advantage in catching fish, right? Because his opportunity cost is lower than Friday's. Now, who has the absolute advantage in catching fish? Well, absolute advantage is measured by productivity. You can see that Friday is actually more productive in both gathering coconuts and catching fish. So you can see that Friday is the person with a higher absolute advantage. Now, who has a comparative advantage in catching fish? Well, Robinson Crusoe, right? Because his opportunity cost is lower. Now, who should specialize in what? Well, this is obvious. We know Robinson Crusoe has a comparative advantage in catching fish. So we know that Robinson Crusoe should specialize in catching fish. And if Robinson Crusoe has a comparative advantage in catching fish, then we know that Friday has to have a comparative advantage in gathering coconuts. So Friday should gathering coconuts. Right? Okay, let's look at two more questions. Should Sidney Crosby shovel his own sidewalk? You want to think about this in terms of opportunity cost, right? So he's a famous athlete, right? So you can think about what is his opportunity cost of shoveling his own sidewalk, right? Maybe his per hour earning rate is $10,000. So if he spends 1 hour to shovel his own sidewalk, he would have to lose $10,000. So he should not shovel his own sidewalk. He should use $100 to hire another person to do this. Then he could get a net gain of 9,900. Right? Okay. Suppose that a skilled brain surgeon also happens to be the world's fastest typist. Should he do his own typing or hire a secretary? Explain. So this is really about the absolute advantage and comparative advantage, right? So you can basically see that the searching has an absolute advantage in typing. However, you can see that it's highly unlikely the searching has the comparative advantage in typing. You can compare a surgeon with a secretary, right? So let's say if the surgeon, let's say to type something, the surgeon might have to give up a brain surgery. Right? In this case, you can see that this opportunity cost is tremendous. So for the surgeon, his opportunity cost of typing is much larger compared with his secretary. So in this case, you can see that he should hire a secretary. So these two small questions are actually quite interesting, right? You could pretty much apply the insight here to your own life, right? Sometimes you have to decide whether you want to outsource something, right? Whether you want to hire someone to do something for you. And you can see that thinking about your own opportunity cost is a nice guidance, right? That is, do I want to hire someone to help me? Do I want um, to to use some money to hire some other guy? Well, you can just compare the money you need to spend and your own opportunity cost, right? If your opportunity cost is too large, then yes, maybe you should spend some money to hire someone to outsource some task, right? Okay, that's for today's lecture.